Hello everyone, it's your boy, no, just kidding. So we're gonna go ahead and continue, but now today we're gonna be talking about rational inequalities. So very similar to the last video, to the last lesson, where we talked about polynomial inequalities. Today we'll talk about rational inequalities. So go ahead and try this do now real quick. So very similar to yesterday's notes. Set each one equals to 0, and we're gonna find those intervals, okay? So we have x minus 2, right? We set it equal to 0, and we have that x is equal to 2. And this one right here looks like it looks kind of funny, but in reality, it's still the same thing. We're going to go ahead and set that entire factor equal to 0. So we have two x-intercepts at x equals 0 and x equals 2. And we do the same procedure. We set the intervals. So let's go ahead and do that a little bit quicker since we had already practiced with this. So the entire interval that is to the left of 0, well, that's all of negative infinity to 0. And keep in mind that we have the little bar right here, so we're going to include it in our bracket. Let me go ahead and hide everything here for get maximum space. Okay, awesome. So from here, we're going to go ahead and continue and get the next interval, and I'm going to go ahead and do it in green. And those are the numbers included between 0 and 2. So that's going to be the interval brackets 0 and 2, and brackets because of this little bar. And the last one is whatever's remaining. And we can see that is all the numbers to the right of 2. And that is going to be bracket 2 to infinities. Okay, so from here, all we have to do is test values. So the test value that I'm going to put between negative infinity and 0 is going to be, let's say, negative 10. A number between 0 and 2, that's a 1. And the number between 2 and infinity, let's go with 10. All we have to do now is test these values into our function. So I'm going to go ahead and check f of negative 10. Will it give me a positive number or a negative number? Hopefully that's not that bad. If we substitute negative 10 into our function, negative 10 minus 2 times negative 10, that just gives me a negative times a negative, and that will be a positive. Okay, and according to this, we want when the function is greater than or equal to 0, so we want the positive. So this should be one of the solutions, and we can see that the next one is going to be, the next one's going to be right here with our test value of 1. So we'll just go ahead and evaluate 1, and it's going to be 1 minus 2 times 1, and we can see that that is going to be a negative times a positive, which gives us a negative. So this right here is a negative. Okay, the next test value that we have is when we have a test value of 10. So we're going to go ahead and say 10 minus 2 times 10. That is positive times positive. That gives us a positive. So this right here is positive. So our solution should be the intervals that are positive. So right here gave us this interval, right? So it's going to be negative infinity all the way to 0 bracket union with 2 to infinity. Okay, so similarly, if you are aware with how the parent function looks like, this should have saved you some time. But if not, this steps, once you get the hang of it, shouldn't take us more than like a couple minutes, right? Let's go ahead and continue. A little heads up from the notes, we have an exam on next Tuesday. And on Monday, we're going to go ahead and review. Okay, keep in mind, I will be on campus this week, so the classes will be at 45 minutes next week, the entire week. All right, so we're doing pretty much the same thing as in the lesson before, but now we're going to be working with rational functions. So keep in mind, you might have holes, you might have vertical asymptotes, and for sure you're going to have x-intercepts. Okay. All right, same expectations for my lab classes. Let's go ahead and do some little check for understandings. So in factored form, we can find the x-intercept by doing what? So go ahead and pause the video, give that a try, and hopefully you're able to get that. Whoops, not that. Set it equal to 0. Sorry about that. I was testing you guys. So not this. It's B. You get the x-intercept by setting the factor equal to 0 and solving for that. Okay. In this question, we can see that we have a vertical asymptote where. So here, pause the video, give it a try. So the vertical asymptote is actually found here. X minus 1 equals 0, so x is equal to 1. So in this one, we have B. Okay, so this right here, keep in mind, this is asking me about the same thing about the polynomials. What goes in the number line? Well, I want you to know anything we're talking about horizontal. So we're talking about x's. So in reality, we're going to go ahead and have vertical asymptotes on our number line, x-intercepts, we just saw that, and holes as well. So in our number line, you'll have x-intercepts on there, you'll have holes, if any, and you have vertical asymptotes, and most likely we will have some. So this one be all the above. Okay, so this question kind of confused us a little, but maybe it was the wording that I used, but I'm considering like what can we physically put brackets on if we're talking about the interval in the domain? Well, for sure, x-intercepts and zeros, right? The roots, that's what we've been doing. How about a hole? Like you have a graph, let's go ahead and draw a simple graph with a hole and the vertical asymptote, YOLO. So like, I'm just gonna say YOLO. Okay, so if this right here was our x-intercept, right, we can physically put a point here. On a hole, on the other hand, it's an emptiness, it's a removable discontinuity in our hole. So this right here, we cannot put a bracket on it. It's not really on our graph. We would actually have to put a parentheses. How about vertical asymptotes? Well, can I physically put a dot in a vertical asymptote? Well, hopefully you see that the graph does all that it can to avoid this. So this would also have parentheses. So the only thing that should have a bracket when you are asked to state the interval at which it is greater than or equal to 0 should only be your x-intercepts. Okay. Digital notebook, guys. So yesterday we uploaded grades, but if you did need any help accessing your digital notebook or whatsoever, please let me know, because I'm assuming everyone, it's now week 6 and I haven't had any of you guys reach out to me. So I graded what was there. If there wasn't anything there, well, then that's what we got in our grade book. Anyways, go ahead and write down these notes. What changes do we see when we're talking about inequalities versus the polynomial versus the rational? So fun fact, it's pretty much the same thing, but now we have vertical asymptotes. We're gonna go ahead and do some right now. Okay, so go ahead and pause the video and let's go ahead and do this example. Okay, so keep in mind in the numerator right here is our x-intercepts, and our denominator right here is our vertical asymptotes. Okay, let's go ahead and identify them. So I'm going to go ahead and set each one equal to 0, x minus 7 equals 0. So x is equal to 7, and x minus 1 is equal to 0. So x is equal to 1. So these are the numbers that I'm going to go ahead and use on my number line. So hopefully it looks now very, very similar. Did I do that right? Yeah, 1 and 7. Okay, now very importantly, this really helped out my students. So hopefully you guys all start implementing it as well. So x-intercept, according to this, my x-intercept was this one. So I'm going to go ahead and put a solid dot right here because of this bar. Now the other value, the x minus 1 equals 0, gave me this vertical asymptote. So I'm going to go ahead and put little dots right here to resemble a vertical asymptote. So now that's going to help me know which one of these can have a bracket or a parentheses. Okay, so let's go ahead and start finding this interval. So right here, all the way to the left of 1 is going to be negative infinity, right? All the way to 1. Can I put a bracket? Even though this has a bar, I cannot, because it's a vertical asymptote at 1. Okay, so the next one, let's go ahead and try it with red. All the numbers between the vertical asymptote at 1 and the x-intercept at 7. So remember, there's a 1 right here, and there's a 7. Keep in mind, this right here is an x-intercept, and this 1 is a vertical asymptote. So the vertical asymptote only has parentheses, and the x-intercept has brackets, according to this little bar, right? Okay, last but not least, we can see that all the numbers to the right of the x-intercept at 7 is going to be 7 to infinities. Okay, from here, I feel really confident that we're able to find the test values and evaluate them. So let's go with negative 10. Let's go with, I don't know, 5. And let's go with positive 10. All we have to do now is evaluate this. So we're going to find out f of negative 10. Is this a positive value or a negative value? So easy peasy. So I got negative 10 minus 7 divided by negative 10 minus 1. So I on the numerator got a negative, and in the denominator I got another negative. So negative divided by negative is a positive. This right here is positive. Okay, let's go ahead and try the next one. I got the value of 5 that is being evaluated on this function. So I'm going to go ahead and see 5 minus 7 divided by my 5 minus 1. So on the numerator, I got a negative, right? 5 minus 7. And on the denominator, 5 minus 1, I got a positive. So this is going to be positive divided by negative is negative. Okay, last but not least, we have this example right here. Evaluated at 10. So we're going to go ahead and get 10 minus 7 divided by 10 minus 1. And we got a positive number on top, right? And 10 minus 1 gives me 9, which is a positive. And I got positive, right? Okay. So in reality here, what we are looking for is this symbol telling us greater than or equal to 0. So I'm going to get my highlighter right here, and it's going to tell me that all the positives are what is greater than or equal to 0. So right here and right here. So my solution should be this answer right here, the interval itself. So negative infinity to 1, and the 1 had a parentheses because it was a vertical asymptote, and the 7 had a bracket because it was an x-intercept. Okay, awesome, possum. Okay, and just a visual representation, we can see that we had a vertical asymptote at x equals 1, right? This was a vertical asymptote, and we can see the graph doing all that it can to avoid it. And then right here, we had an x-intercept at x equals 7, so where 20 touches the graph. So we can see exactly where the graph was above the x-axis and below the x-axis, right? And then right here where it's not shaded blue, we can see where it was below the x-axis. So pretty much telling us the little visual representation, right? Except that I did this one to be just greater than. But if it was greater than or equal to, it would be as we just saw with the bracket on our 7. Okay, cool. Alrighty, so let's go ahead and try this one more. So go ahead and pause the video and give this one a try. So, okay, so this should be your x-intercept, and this should be your vertical asymptote. Okay, so I'm gonna go ahead and do my number line, right? 2 little sticks, and according to this, my numerator, right? If I go ahead and set it equal to 0, x plus 2 equals 0, so x equals -2 is an x-intercept, so at -2. Okay, the next one says x minus 2 equals 0, so x equals 2 is a vertical asymptote, so x equals 2. Okay, let me go ahead and label this before I forget. So x-intercept, right, at -2. So I'm going to go ahead and give it a solid dot. That means my x equals 2 was my vertical asymptote, so I'm going to give it a little vertical asymptote in my number line. And I'm going to go ahead and try to find test values. So let me go get blue. So all the numbers to the left of -2, it's going to be negative infinity all the way to -2. Can I put a bracket on there? Well, sure I can, because it's an x-intercept. And let's continue. All the numbers between 2 and the vertical asymptote at 2, sorry, -2 all the way to the vertical asymptote at 2. So that's going to be bracket -2, and then 2 with a parentheses. I know this says little bar, but it's a vertical asymptote, so I can't really put my finger on the graph there, right? Okay, and all the numbers between 2 and positive infinity. Okay, so both of them have parentheses because, again, this is a vertical asymptote. Okay, alrighty, so let's go ahead and continue. Let's pick test values. So I'm gonna go ahead and get sure, negative 100, -2 and 2, a number right there is 0, right in the middle. And then from 2 to infinity, I'll get 100. So let's go ahead and evaluate it. So evaluate at -100. is that going to give me a positive or a negative? Okay, so all we have to do is substitute it. Plus 2 divided by negative 100 minus 2, sorry about that. And we evaluate it and we see that negative over a negative gives me a positive. So all of this graph will behave above the x-axis. So let's try the next one. What happens when it is 0? Well, when it is 0, it's going to tell us how a graph behaves between negative 2 and 2. So I'm going to substitute. So 0 plus 2 into my original function and 0 minus 2. And get a positive on top and a negative in the bottom, which simplifies to just a negative. So this right here is negative. Let me change the marker. And the last one says when the function is evaluated at 100, so the test value was 100. And if I substitute, I get 100 plus 2. I know some of us can do it in our heads really quick. That works the same way. So 100 plus 2, that is positive. And the 100 minus 2 is still positive, right? Which all of this simplifies to positive. So our solution should be, in this case, all the values for which the function is less than or equal to 0. So we're looking for the negatives only. So according to this, this should be our solution. So our solution should be from negative 2 bracket all the way to 2 parentheses. Remember, this right here was the x-intercept, and this right here was a vertical asymptote. Awesome. Ooh la la. Let's go ahead and see this one right here. So don't be intimidated. Most of the times you'll probably see 3 or 4 different factors. So keep in mind this will probably be the same procedure for the rest. It's just a little bit more tedious, but it's the same procedure. Okay. Keep in mind this right here are x-intercepts, and these two right here will be vertical asymptotes. So let's go ahead and solve for them to find their location. X minus 3 equals 0. So x is equal to 3. That is an x-intercept. We have x minus 10 equals 0. So x equals 10 is a vertical asymptote. And we got another one equals 0. That's x equals negative 2. Okay, so let's go ahead and graph this in our number line. Okay, so this right here is going to be from least to greatest, negative 2, 3, and 10. Okay, so from here, all we have to do is find our intervals. But before we do that, let's go ahead and label this. This would be my x-intercept, and these are our vertical asymptotes. I know most of us won't mind that, but it is good to know. But I understand, like, since this doesn't have a bar right here, it probably doesn't affect our brackets, and so, but it is always good to know what you are working with. So right here, I got all the numbers between negative infinity and negative 2. And then the numbers right here from negative 2 to 3. Okay. And then again from 3 to 10. Okay. And then from 10 to positive infinity. Okay. So keep in mind, this was only a grade less than. So we're looking for the negatives only. And we can pick test values right here. So let's go ahead and do a number between negative 2 and negative infinity. I'm gonna go with negative 10. A number between negative 2 and 3, that's 0. Number from 3 to 10, I'll go with 5. And from 10 to infinity, I'll go with 100. And all you have to do is test this out. So the function at negative 10, is that gonna be positive or negative? Well, let's find out. Negative 10 minus 3 divided by negative 10 minus 10 times negative 10 plus 2. Okay. So according to this, I got a negative on top divided by a negative times another negative. So when my students were like, oh, well, can't I just go ahead and cancel these out? Sure, it simplifies to 1. And then you just have 1 over negative, which is still negative. So if that works for you, perfectly fine. I do not mind it. And if just the main idea of, hey, are you finding out just the sign? So f of 0, let's go ahead and check that. Keep in mind, that's how I draw my divisions, right? It doesn't mean less than or greater than. Okay, so f of 0, I got 0 minus 3 divided by 0 minus 10 times 0 plus 10. And I got negative divided by a negative times a positive, right? So we can go ahead and see that I got a negative on the numerator, negative denominator, and 1 over a positive. So this was a positive. Okay. The next one is the function evaluated at 5. We could do the same thing. We can go ahead and see that this is going to be 5 minus 3, and then 5 minus 10 times 5 plus 2. So we got positive on the numerator, negative, and then another positive. So this right here gave us a negative. Okay, last but not least, we got the function evaluated at 100. And we can go ahead and see 100 minus 3 is positive. And we got 100 minus 10 and 100 plus 2. So all of this was positive in the denominator, giving us a positive. Okay, so our solution should be the following. We should be working with whatever is less than 0. So our negatives right here. So our solution should be the interval from negative infinity to negative 2, union from 3 to 10. Yes, all right, cool. Alrighty, for practice, guys, I went ahead and gave us these 3 problems, so they're not that bad. They are already deposited into your digital notebook, and I'll be checking that on Tuesday. Okay. For the exit ticket, guys, I want you to go ahead and give this a try. This was also one of those exit tickets that I gave as an optional that will replace your lower exit ticket. So if you have that, shoot it to me on a personal chat or email, or and I will go ahead and replace it with one of your lowest grades, right? As always, guys, this has been a pleasure. So thank you so much, and I'll see you on the next one. Bye.